Okay, so in this lesson, we're going to see how to calculate the percentage purity of a compound. First, we're going to look into an easy problem, and then we're going to move into a much more advanced problem. So in this problem, we can see that we have an impure sample of calcium carbonate, which weighs 2.1 grams, which was reacted with HCl, and the reaction produced 0.62 grams of CO2. So usually this might be also given in volumes of CO2, but that should not be a problem with you. If you've seen the previous videos, you know how to calculate the moles using volume. So, so first we need to write down the equation. The equation is calcium carbonate reacts with HCl to produce a salt. In this case, the salt is going to be CaCl2, and as it's a neutralization reaction, it's going to produce water and CO2. CO2 because there's carbonate. So we need to balance this. So to balance this, we need 2 moles of HCl. So the reaction ratio is 1 is to 2. So I need 2 moles of HCl to react with 1 mole of calcium carbonate sample. So the question said that we have produced 0.62 grams of CO2. So we have produced, let's see, 0.62 grams of CO2. So the first thing we're going to do is we're going to figure out the moles of CO2 produced. So the moles of CO2 produced. This is going to be mass in grams by molar mass in grams per mole. So my mass is 0.62 grams, and the molar mass of CO2 is, the molar mass of carbon is 12, plus the molar mass of oxygen is 16, and I have 2 of those. So that's that in grams per mole. So this is going to be 0.62 divided by 44. So this is going to be 0.0141. 0.0141 moles of CO2. The grams are going to cancel out. The mole is going to go to the top. You know that by now. So the next step is going to be to find out. So I know the moles of CO2. So I know that this thing produced 0.0141 moles of CO2. So according to the molar ratio, so this is 1, this is 1 as well. So each mole of calcium carbonate, so each mole of calcium carbonate is going to produce 1 mole of CO2. So as we have produced 0.0141 moles of CO2, so this must have been produced. This must have been produced by how much CaCO3? This many moles must have been produced by the same amount of calcium carbonate, right? So once we figure that out, so just write this down here. So moles of CaCO3 that reacted is going to be 0.0141 moles. So now we're going to figure out the mass of that CO2. So the mass of CaCO3 that reacted is going to be the number of moles times the molar mass of CaCO3, which is 100 grams per mole. So this is basically the rearrangement of the formula that we know, that moles is equals to mass by molar mass. So if we rearrange that, So mass is going to be moles times molar mass. So we're just doing this here. So the moles are going to cancel out, and we're going to be left with just grams of CaCO3. So which is going to be equal to 1.41 grams. So 1.41 grams of CaCO3 reacted. So this is the information that we need. So this is the information that we need. So this is 1.41 grams. So this much is only CaCO3. But we have taken 2.1 grams of the sample. This was the whole sample. So imagine you went out and you bought this sample. You bought this sample from a shop. You bought 2.1 grams of CaCO3. So basically, let's imagine if this is the CaCO3 molecule, or if this is the sample, so the whole thing is 2.1 grams. However, only 1.41 grams is actually CaCO3, and the rest are impurities. This bit here is basically not your CaCO3. These are impurities. This could be minerals and other stuff. So now I know that out of the 2.1 gram, this is 2.1 gram is the whole thing. So now I know that the impurities is going to be 2.1 minus 1.41. So that is around 0.69, close to 0.69 grams. So this is 0.69 grams. So now, the formula for calculating the percentage purity is the mass of pure sample divided by the mass of impure sample. So you're just basically figuring out times 100%. So you're basically just figuring out how much of the sample is pure. So now if we do this, so the pure sample was just 1.41 grams, and this is the whole of it. This is the whole sample, impure, the whole sample. So which one? That is 2.1 grams times 100%. So if you do the math, so this is 67.1% pure. So if they asked you, so you should be able to figure this out now, if they asked you the percentage impurity, I mean, they don't usually ask, but if they did, if they asked you about the percentage impurity, so what are you going to do? So in percentage purity, you are figuring out how much of the sample is pure. So in percentage impurity, you're going to figure out how much of the sample is impure. So we've already figured out here the mass of the impurities here, which is 0.69 grams in this case. So this is going to be the mass of impurities divided by the mass of impure sample, the whole sample. Because if it was pure, it's just gonna be only calcium carbonate. But unfortunately, the world is not perfect, and we do not get 100% calcium carbonate. So the mass of impurity is going to be 0.69 divided by the whole sample, which is 2.1. This is gram, this is gram. Grams are going to cancel out times 100%. Excuse me. Times 100%. So this is, I mean, you can just, you know that it's going to be 100 minus 67.1, but let's just do it. So this is 32.9. So this is 32.9% impure. So this is 32.9% impure. So that's how you do simple purity calculations. In the next part of this video, I'm going to talk about how to do a much more advanced problem that requires titration. So one thing that I'd like to mention is why this method works. The idea is that the other impurities in the sample will not be producing any calcium carbonate. Sorry, any carbon dioxide. The idea is only the calcium carbonate in the sample, only the calcium carbonate reacts with HCl to produce the CO2. The other impurities in the sample is not going to produce CO2. That's the idea. So once we know how much the CO2 was produced, in this case we know that the CO2 produced was 0.62 grams. So we know that 0.62 grams of CO2 is produced. So that only means that this must have come from calcium carbonate reacting with excess HCl. The HCl needs to be in excess. That's because you don't want the reaction to stop because the HCl ran out. You want the reaction to stop because all the CaCO3 ran out. In that case, you can account for all the CaCO3 present in the sample. So that way, to summarize, we figure out how much CO2 is produced. We figure out what's the amount of CO2 produced. In chemistry, when we say amount, we basically mean moles. And then we use the mole ratio to figure out the moles of CaCO3 present in the sample. And from the moles, we can figure out the mass of the CaCO3 in the sample. So this is only CaCO3, nothing else. This is pure CaCO3. So that way, we're going to solve these type of problems.